In this video, we're going to be using a known value of a trigonometric function to determine other function values. So for this example, suppose that the cosine of theta is the radical 5 over 3 for the acute angle theta, and we're going to evaluate the tangent of theta. So first let's recall that the cosine of theta is actually our adjacent over our hypotenuse, which means that if we have the cosine of theta is the square root of 5 over 3, that we can then say that our radical 5 is our adjacent side and that our 3 is our hypotenuse. So remember that these all come from right angles. So if you need to, you can draw a triangle. Sometimes I find that this helps a lot. And let's go ahead and let's make that our theta. So our adjacent side would be right here, and our hypotenuse would then be here. Now we are looking for tangent of theta. So that's what we want, is tangent. Now tangent of theta is our opposite divided by our adjacent. So we already know that we have the adjacent side of radical 5. But we need to find our opposite side. And that opposite side is this value right here. So we can call that x, we can call it a, whatever we want to call it. So I'm going to use Pythagorean's theorem to help me with this problem. So Pythagorean's theorem says a squared plus b squared equals c squared, where c is our hypotenuse, so we know this is going to be our 3 squared. And we're going to go ahead and make our a squared be our adjacent side. It really doesn't matter. We're going to do that. And I mean, if we wanted to, we could really call that bx, since that's what we named it. And as we go through this, we're going to see that a square root and a square cancel each other out, and that's going to drop down our 5. So we have 5 plus x squared equals 9. Then from here, we're going to go ahead and we're going to move over that 5 and get x squared equals 4, square root both sides. And that's going to give us x equals a plus or minus 2. And in this case, a negative 2 isn't going to help us because you can't have a negative distance. So really, we're just looking at x equals 2. So we found our opposite side that we were looking for. And so we can put the 2 on the top. And we don't want to leave it with a radical in the denominator, so we need to rationalize this. So in order to rationalize, we multiply both the denominator and the numerator by the square root of 5. Now what's going to happen is on the top, we're going to have a 2 radical 5. Now there's a lot of different ways to talk about how the bottom comes out. The answer is that it's a 5. But how, right? Well, there's a couple ways. So first of all, you can think of this as the square root of 5 times 5, which is 25, which comes out to a 5. That's one way. Another way that you can think about this is that technically this is a square root of 5 quantity squared, which we know those cancel out, giving us just the 5 again. So again, there's a couple different ways you can think about how you get that 5 out, but either way it's a 5. So we're then able to say that our tangent of theta is 2 square root of 5 over 5, and we're now done with this problem.